Okay, everybody, we're back, and I had to check my email because I had to figure out what my next video was going to be and kind of point it out. I wanted to keep it layer 2 and get the layer 2 situation situated. Because that's typically how you're going to build your network, is from the ground up. You're going to put all your equipment in, and then once you get your equipment in and situated, you're going to cable it up and um, hang on one second, please. Anywho, like I was saying, you want to build from the ground up. So you put your equipment into its racks, you cable it based on the diagrams and how you've written out on paper, because typically that's how your project is going to start. You know what you want to buy, you buy it, then you put it into the racks, you cable it based on specifications. Then you get in, you start setting up your layer 2 domain. Then you get your frame relay set up. Then you get your layer 3, so your network. You start routing, and then your layer 2 domain with your VLANs and your BTP and your router on a stick. That all comes together, and eventually layer 3 turns into making sure that you have full reachability through your entire network. And then once you have reachability, then you can start locking it down with ACLs and your firewalls and things like that. So I wanted to keep it kind of on track for that, because that's how you logically want to build your network. The OSI reference model is 1 through 3 is how we look at it in the network side. Some layer 4 with with OSPF and TCP and UDP and stuff like that, and port numbers with ACLs. So you're going to really want to focus on building it logically from the ground up, because that's how we networkers work. We work from the ground up. Physical, logical, and then physical, data link, and then network. So, with that being said, I'm going to get onto the routers here, and I'm actually I'll be able to point things out. And currently, Exeter, I'm going to keep more of it on here so that you guys can see it. So, Exeter, right now, and we've got the frame relay network that we have set up here, 172.20.136. So, what we're going to do is the Exeter router. What we're going to do is this. Now, per the requirements of the lab here, let me scroll down here. Let's see. Okay, that's layer 2. And we already have all this pretty much situated. The network design is already pretty much figured out. We know what we're going to do. Redundant switch network, so we have, we've selected the root bridge and defined VLANs and their names and their network addresses, stuff like that. We've already done all that, okay? All network addresses, number of hosts per network, did all that. Link speeds, we know what we're looking at. Design to secure ports and the switch using port security. Not yet, okay? Because we haven't actually connected anything. Typically, you can do it now and go in and set up port security to where and I'll explain how it goes. It's actually really straightforward. But now that we've done that, so I'm going to scroll down here just a little bit here, and what we're going to do here is, where is it? A lot of boxes. This is more of a print it out and handwrite it in. Yeah, I don't do that. So, they want you to do DHCP. Well, yeah, we're going to do DHCP later. So, here we go. Configure switch network and VLANs on link to HQ router. We've already done that. Okay, this is all done too. We haven't created names. We can always go back and do that. It's just a matter of going into our BTP server, going into the VLAN, and giving it a name. Real simple. We've got static addresses on all of our VLANs, or for all of our switches, and let's see here. We've got router VLANs configured. We don't have a DHCP pool set up yet because I haven't gotten that far yet. That to me, that's a service. So the first things you want to do, you could do it this way too if you wanted to, but to me it makes more sense to get layer 2 set up than to get layer 3 set up. Once you have reachability through your entire network, everybody can ping everybody else. That's when you start segmenting it down. That's when you start locking it down, and you set up your DHCP, you set up your DNS, you set up your security, you set up your firewalls, your ACLs. All that stuff comes in tied. That's a CCIE mentality. You want full reachability, because if you start adding pools in and then you goof up and you add a wrong statement in somewhere, you're going to get hosed. So easier just to get full reachability than lock it down. So we're near the bottom here. Now, here's where the fun part begins. Configuring WAN links in OSPF. Now, it does say right here, okay, PPP, perfect example. Connect the routers with using dedicated serial WAN links at 64 kilobits per second. That's what it doesn't default to that, but we'll set it up that speed. Assign IP addresses to the serial port links, and configure PPP encapsulation between HQ and Plymouth. And I will select. I hate when that does that. HQ and Plymouth are right here. HQ and Plymouth. This is a PPP. Now, you may be asking, well, why do you have two connections? Well, I'm going to make it a multi-link. Because, let's just say, for instance, your job, they want you to, 64K is pretty slow. I mean, it's just a little bit faster than 56K. So, it's slow. Really slow. Like dog slow. So if you're pulling, let's say for instance, there's some HQ and the IT department monitor Plymouth, Pool, and Bournemouth. Well, if you guys are running 56K and you max out your circuit speed, let's say you go 55.2K per, 55,200 kilobits per second for a couple of seconds. If you're throwing SNMP across your network and they have an SNMP traps being sent every so many minutes or seconds or what have you, whatever you decide to set your interval at. If you have SNMP going across here, and then it drops into like a syslog server somewhere over here, if SNMP doesn't go through, SNMP is going to throw a trap and say, hey, I can't talk to this guy, check it out. So it's going to give you a trap and say they're down. So then you're going to be on the phone to them, hey, can you check the equipment? Is it powered on? Did you guys lose power? You start freaking out. 64K, I don't like going that slow. So by default, they go 1.5K or 1.5 meg or T1. So that's what we're going to run it at. And just simply for the fact that it's easier to deal with that way. So beyond that, we're going to see what we have running here. So what I'm going to do is I'm going to click in here. I'm going to click on this guy. And serial 0/1 and 0/2, 0/0 and 0/1. So you want to make sure you keep those pretty straightforward. Because that's going to be which interfaces you put into the bundle. So I'm going to make this a PPP multi-link when I get done with it. So we're going to do this. We're going to go to serial 0/2 and 3. So what we're going to do, we already have our range. It's /30. So I know 65 and 66 are going to be my IP addresses. So what we're going to do is we're going to go config T. We're going to do interface serial 0/2. We're going to do encapsulation PPP. There. Now that will bring down the other side of the link because of the fact that it's HDLC by default. So what we're going to do is we're going to do the same thing with this guy /3. We'll type in encap PPP. Done. Now this router right here is running PPP. Then we're going to click on Plymouth, and we're going to do the same thing. So actually, I'm going to bring this guy up here. I'm going to bring this guy down here so you guys can see this. And do this. So I'm actually I can see it on both of my monitors. So we're going to config T or show IP interface brief, so you guys can see this 0/0 and 0/1. So we're going to go config T, type in interface serial 0/0, type in cap PPP. We're going to go up 1, and then do the same thing. Oop, I'll do that. Now, we have encapsulation PPP. Now, how come it didn't squawk? Because they're shut down still. I did that on purpose. So, we're going to type in, you don't want to put an IP address on the individual links. Well, why not? Because you just don't want to. So what we're going to do is we're going to exit. We're going to type in interface multi-link 1, and then question mark. I know it's running a little slow. It happens. Those are all of our options. Now we do have some features. What we're going to do is wait for it to do its thing. IP address. Interface Internet Protocol config commands. type in IP address is going to be 172.20.165.255.255.255.252. No shut. So now it's turned on. So we're going to type in, do the same thing over here. Actually, let me do this. And show IP interface brief. Show IP interface brief. And now you see multi-link 1. It's down. That's because there's nothing in it. Okay, these guys haven't been put into it yet. So I'm going to do this. I'm going to exit. Type in interface multi-link 1. IP address is going to be 172.20.166 or 0.166 255.255.255.255.252. Oh, we have an issue here. Whoop. 160. Oh, we do have an issue. See, that's why, I didn't plan that, but we're gonna work around that. Since I don't have any other ranges above that I can see. 128. We're just going to bump this up to the next level. We're gonna, because 160, we're gonna go, we'll come over here, we're gonna click on this guy. We're gonna go config T, we're gonna type in interface multilink 1, IP address is gonna be 172.20, and because we're already on the 248 range, 168, so, okay, that's my fault. 160. Technically 164 would be the next one. We're going to go to 168. So we'll do 169 and 170. Not a problem. We're going to go 20. Click back in this guy. 20.1 or 0.169 and 255.255.255.252. Same thing up here. 170. Now we shouldn't have a problem with that. There it goes. No shut. And we're going to now go into interface 00/2, and we're going to say it should give us the opportunity for multi-link. LM There we go. Sorry, sometimes you do that. PPP multi-link, and we're going to type in group and 1. So now, and then we're going to do the same thing with /3, and we're going to do the same thing with this guy. Is PPP multi-link group 1 and 00. Alright, so end. Show multi-link interface multi-link 1. And you're like, well, how come it's not working? It's down. Because I haven't turned any of these on yet. That's why. No shut. Same thing with this guy. Config T, interface 00/0, no shut, no shut. Hey, what do you know? Now, before we get all start jumping up for joy, I actually wanted there to be just a little bit of suspense. So you see how multi-link 1 came up. So we're going to do end show IP interface brief. So now it's up. So the same thing here. Show IP interface brief. And it shows that it is up. Can I ping across? 172.20.0.169. And I can ping across. So what does that mean? Well, show interface multi-link 1. LCP is open, multi-link is open, everything looks good, everything's going across. And so we're going to do show interface status on a router. We'll show you what's going on. 00/2 and 0/3. Notice how they both have stuff going across them? That's a good sign. Show interface 00/2. Notice how it defaults to 1.544. There's the same thing with this one, 0/3. 1.544. Okay, so that's what you got to remember. It defaults to T1 speed. So right now, what we have going across these two links, we have two 1.5 megabit circuits, or two T1s. So we have a 3 megabit connection between here and here. Okay, so that's what we wanted. It's not hard to put stuff into it. All we did is, remember that ether channel thing I was telling you about? How when you have two trunk links between two switches on fast Ethernet or gig interface ports, what will end up happening is it'll be two 100 megabit or two 1 gigabit, depending on how you have it set up. Well, if you put those into an ether channel or a port channel, it becomes one 200 megabit connection. Okay, so you're able to load balance across each one of them. The VLANs still cross, and then you can set the root bridge, and you can set your load balancing up accordingly for your per VLAN spanning tree. With this, what it does is it takes the two serial interfaces, and in the iOS, it views it as one, the multi-link group. So if, say for instance, one of these guys was taking error, so you can do a is it a service module? No, it doesn't have it in here. If you do show interface multi-link, and then you can specify the group number. So we're in 1 right now. So it's up, it's transmitting, it's open, so we know that it's working. I was able to ping across it, which is good. So we may see some errors because this is a logical. It's a virtual router. We may see some logic or some protocol drops, but until we see input errors and CRCs and frames, stuff like that, then we know we have an issue. And then at that point, we can go in and be like, okay, well, which one's doing it? And then we do show interface, and that'll let us see what's going on. So we can go in, we can say, okay, it's a .1 key virtual LAN. We know that it's 100 megabits full. There's no errors on it right now. And then we can keep going. I'm going through. It's taking some hits on some things. It's dropping some protocols because it doesn't know what to do with them. Then we have our sub interfaces, and this is what I do every day. So I'm actually really I'm used to looking at these type of outputs all the time. If there's issues, this is where we first go to look. Interface drops aren't bad. Fast 1 is administratively shut down, which means it's physically shut off. Serial 1, HDLC, they automatically 1.544. You can adjust the bandwidth to whatever you want. I mean, you can do 2 million if you wanted to, but for the sake of argument, we're not going to go that high. And we're going to continue up. Oh, and see, here's our first multi-link. PPP, LCP open, multi-link open. Now, we could go ahead and there's no CRCs, no frames, and if I was receiving CRCs or something like that, I would be confused. I would be concerned, but we're not. Now it says queuing strategy is weighted fair queuing, suspended using FIFO. FIFO is the default queuing, which means as soon as it comes into the queue, it's shipped right back out. It says weighted fair queue on circuits like PPP, where they're multi-link. That's usually how it goes, because you want to weight your traffic to some degree, because at that rate you're able to determine who goes first. So when you're load balancing across two different things, by default that's what Cisco IOS will do. So as soon as you put two serial interfaces into a multi-link bundle, or like in this case we're a PPP, if you throw it into an IMA bundle for ATM, it'll do the same thing. It'll class-based weighted fair queuing will kick in. It's Cisco IOS. It's you use the MQC, the modular quality of service command line interface, to go in there and configure that. You'll hear a lot of stuff like that coming out of me now, because well, I'm studying for the CCIE. So we're gonna kill that, because we really don't need to know all this information. So the point is, this is working. Okay. So you do show IP interface brief, and I'm going to ask everybody a question. Why does it show that serial 0/2 and 0/3 on the exiter router, which is this section over here? Why are these guys unassigned IP addresses? Why don't they have IP addresses? Any guesses? I'll tell you why. Because of the fact that these guys, if you were to throw an IP address on there, there'd be a conflict with this guy. So because these guys are logically bonded together in the multi-link group, you don't want to put an IP address on them. You could, but as soon as you do, you'd have to take the IP address off in order for them to go from a single interface by themselves to a multi-link bundle. So that's PPP. We have PPP set up, which, you know, yay us, we got that done. Now I won't put CHAP on until later on. So configure frame relay with connections between serial 0 and ports 1 and 2. Packet tracer provides sublinks for this, and that's true, it does. Connect the serial WAN link between HQ and the serial. Okay, well, yeah, that's pretty obvious. We're not going to do any wireless here, because of the simple fact that we don't have the capability in GNS3. And add OSPF Area 0 routing protocol to HQ, Plymouth, Pool, and Bournemouth routers. Okay, pretty straightforward stuff, right? And then it says use a default route, and not a problem. Not a situation. Nothing to be concerned about. So what we're going to do is frame relay. I'm actually going to stop the video because I've talked enough about PPP, and I will do a PPP video and I'll do a frame relay video. So you see PPP connected, and actually let me do this. Plymouth is down here. This is Plymouth right here. I'll do Plymouth, and then I will do Exeter. So I want to ping the opposite ends. So ping 172.20.0.169, and I want to ping 172.20.0.170. And we can ping across. That's what I wanted to verify. If you can't ping across, there's a problem. So just because it shows up, it may not be up. Does that make sense? So I'm going to write mem to those and write mem to these. That's the first bit of configuration we've done on Plymouth. We've done quite a bit on this guy. So in case, you know, GNS3 craps out on me, I want to make sure that it's good to go. So I'm going to close Plymouth out for the time being, because we don't need him open right now. So as of right now, we've got PPP working across, so that's good. I'm going to configure frame relay in the next video. So I hope this has been informative for you, and I would like to thank you for viewing.